Okay, it's the final part of the Rohde Schwarz SRV. Got it working finally. Wasn't actually that difficult really. Basically, it needed total recapping. Let me just show you what I've done. I've replaced these electrolytics here along the main power supply capacitors. These have been changed. These are supposed to be two. I think they're 12 microfarads each, 24. I've actually got two 33s in there, which is about the limit of what this valve can cope with. So replace these electrolytics and some of these other ones down here. Now basically this is the voltage divider basically. So you've got 100 volts, each tube flashes over about 115 volts. So we've got about 115 volts here and about 250, 240, 250 volts here. That's just a current limiting resistor because you can't put raw mains straight onto those tubes, it will just burn them out. So basically this is supplying 100 volts here, it goes through a dropper resistor. Now this capacitor here was totally open, so I've replaced that, and that capacitor used to be under the underside of the board underneath here, and that capacitor is now here on the board, and that's a high voltage, that's a 10 UF, and that fits the second grid of the oscillator valve. This capacitor here, as you saw in the last video, is a cathode bypass. That's been replaced, and that's actually that blue Nichicon under there. You can see there's another one further back behind the valve. There's also another capacitor here I've replaced. Now when they were originally out of the factory, the underside of the radio was actually full of capacitors, because in those days a capacitor of that size was huge. But what I've done now is I've still got one more capacitor to add, and I haven't done that yet because I haven't worked out how I'm going to do it, because it's a bit awkward, and I'll show you, come to that in a minute. Those two blue capacitors you see there are these two capacitors here. They're the main smoothing. They're what value are they? 22 UF at 385 volts. You've got about 350 volts on there, so they're within their working limit. These capacitors here, funny enough, even though they date from 1944, and they're supposed to be, well, it looks like they're electrolytic. They're an old Philips capacitor, and you can see that. But they're absolutely fine. They work fine. They got good capacitance. They hold their capacitance well. So I'm not too bothered about those. And interestingly enough, this capacitor here, that was originally on the underside of the board, I don't know where it is, I've got it in the workshop here somewhere, I might throw it in the bin. It measured okay on capacitance, and the ESR measured reasonably well. But what I did was, when I charged it up, I charged it up with 60 volts. It's a 100 volt capacitor. Charged it up, measured the voltage across it, and there was nothing. So it's just leaked away to nothing. So I replaced that capacitor with that Sesco high quality capacitor there, and that's basically that's what brought it back to life on the lower frequencies. And let me just show you now. Now I've got the voltages correct on all the valves. It seems to be working fine. So 109 hertz to 750 hertz. Let me just put some more light on so you can see a bit better. Help me see a bit better. So this is the range selection, and we were on that. Yes, we were on the 109 to 750 hertz range, and you can see on the scope we've got a nice strong signal. Actually, it's quite a powerful signal. And let's just check it with scale calibration. I haven't checked scale calibration. I've just basically got the oscillator working at the moment. So if we're on the 109, so there's the 109. So let's set it to 180 hertz. That's there. You can see, and we'll measure the with the cursors on the scope. Got that lovely smell of old electronic equipment getting in here now as the heat is. Alright, it's 198 hertz, so it's going to need a bit of trimming with various things, but it's certainly working pretty well. Far better than it was when I first got it. It doesn't seem to stall the oscillator anymore. Let's try on the higher frequencies. As you can see there, waveform's not particularly great, but you know, it is is being driven pretty hard. I'm not too bothered about that. And these things were never designed to have a very clean sine wave. They were just designed as an audio source, really. As you can see, it's working fine on the higher, in the top end range. Absolutely no problem. Actually, on the very higher frequency, it seems to work better. That's all pretty compensation on that valve. So yeah, it's working absolutely fine. Nice little set. I'm never going to use it, but it's a piece of history, and it's Rohde Schwarz make good quality stuff. And I think it'd be nice if I never use it. I might donate it to the local museum. Actually, there's Arundel working museum down in Arundel. You should visit it. Actually, it's a super old museum. It's all machinery and stuff, but they've got a radio workshop in there, and it's well worth a visit. It's open at the weekends, and it's a reasonable price to get in. You can get to the Arundel station in West Sussex. Just get on the train, and the station is directly opposite the museum, so it's an easy enough way to get there, or just come off the A29, going down towards Worthing. But I might donate it to them if I'm not going to use it, because I think it's not going to be useful in anyone's workshop. To be honest with you, it's a piece of history more than anything. But thanks for watching. I've enjoyed working on it, and I hope you've had some interest as well.